Satellites 101. A satellite is any object in space that orbits or revolves around another object. There are two kinds, natural and artificial satellites. The Moon is a natural satellite that revolves around Earth. All of the planets in our solar system are natural satellites of the Sun. Artificial satellites are made by humans. Artificial satellites are high-tech tools that orbit Earth. They are like space robots that do many jobs people can't. Even though we often aren't aware of them, artificial satellites have played an important part in our lives since Sputnik 1 was launched in 1957. Artificial satellites allow us to do everyday things, such as use our cell phones and select TV programs from hundreds of domestic and international channels. Satellites help captains navigate ships and meteorologists predict the path of dangerous storms. Thousands of satellites now orbit Earth. Similar to satellites are space probes, which usually explore other planets, moons, or asteroids within our solar system. They can also travel to the far reaches of space, sending back valuable information. Satellite anatomy. Satellites are built for specific jobs. On the outside, they may look like a barrel or a windmill and have paddles, solar panels, or sails. Inside, satellites contain mission-specific scientific instruments. The payload includes whatever tools the satellite needs to perform its work, such as sensitive antennas, high-resolution cameras, and communication electronics. The bus is the part that carries the payload. The bus holds all the parts together, provides the electrical power for the computers and communication equipment, and the power to move the satellite forward. Solar sensation. Satellites use solar energy from the sun to run their equipment. The flaps, wings, panels, or the satellite shell can be covered with solar cells. These cells convert the sun's energy to electricity. A satellite never pays an electric bill. Computers function as the satellite's brain. The computers receive information, interpret it, and send messages back to Earth. Advanced digital cameras serve as the satellite's eyes. Sensors are other important parts that recognize light and color, heat, water, minerals, and gases. Sensors record changes in what is being observed. Radios on the satellite send information back to Earth, where antennas receive the signals. Linking up. Downlinking is when a satellite converts the information it collects into a radio signal and sends it back to Earth. These signals travel through space and are received at an Earth station or dish. Sending signals back up to a satellite is called uplinking. Outstanding orbits. Artificial satellites use gravity to stay in their orbits. Earth's gravity pulls everything toward the center of the planet. To stay in Earth's orbit, a satellite's speed must adjust to the tiniest changes in the pull of gravity. The satellite's speed works against Earth's gravity just enough so that it doesn't go speeding into space or falling back to Earth. Rockets carry satellites to different types and heights of orbits, based on the jobs they need to do. Satellites closer to Earth are in low Earth orbit, which can be 200 to 500 miles, 321 to 804 kilometers high. Gravity is stronger closer to Earth, so these satellites must travel at about 17,000 miles per hour, 27,358 kilometers per hour, to keep from falling back to Earth. Higher orbiting satellites can travel more slowly because gravity's pull isn't as strong. Hunks of junk. A space shuttle traveling in low Earth orbit smacked into a fleck of paint that dug a pit in a window nearly a quarter inch 6.35 millimeters wide. Space might seem empty, but what's really out there is an orbiting garbage dump. Leftovers from early space missions, such as gloves, lens caps, bolts, rocket motors, and meteoroids, too. These objects slam into spacecraft at speeds of 170,000 miles per hour, 273,588 kilometers per hour, or more, causing serious damage. Satellites that follow a lopsided elliptical or oval-shaped orbit do so to get a closer view of Earth. At 540 miles, 869 kilometers up, satellites in polar orbit travel from pole to pole and circle the Earth 18 times a day. Other satellites orbit over the equator, 22,300 miles, 35,888 kilometers up. They move at the same speed that the Earth is turning. These satellites are in stationary orbits, meaning it takes 24 hours for the satellite to circle our planet. The Earth takes 24 hours to spin on its axis, so these satellites appear to stay over the same spot. Satellites work. Scientists design satellites to collect many different types of information. Scientists design and place them into orbit according to what kind of data they are collecting. Communication satellites, or ComSats, allow us to use cell phones and send emails and faxes across the globe. They allow us to broadcast television and radio programs around the world and make phone calls while flying in an airplane. The first live broadcast across the Atlantic Ocean was made in 1962 by an experimental satellite called Telstar. Before then, news had to travel by telegraph, telephone, or cables. Now, we can communicate with the most remote places by bouncing a signal across multiple satellites. Earth observational satellites collect information on temperature, oceans, wildfires, animals, and even volcanoes. Sometimes, these satellites are called environmental satellites. They record changes in the Earth's surface and atmosphere, including pollution and destruction of forests caused by human activity. They use powerful cameras to take pictures using light rays, X-rays, and radio waves. Environmentalists, farmers, miners, and fishermen find this information increasingly valuable. Other satellites, such as military or spy satellites, have taken pictures of Earth since 1960. Officially named reconnaissance satellites or spy-sats, they spy on other nations. Spy-sats relay coded messages, monitor nuclear weapons, observe enemy armies, and can eavesdrop on many forms of electronic communication. The advanced technology developed for use in spy-sats has been expanded for other uses. Industries use imaging satellites to find oil or mineral sites. Law enforcement uses them to find where illegal drugs are grown. Satellites have even traced pollution back to the polluters. Research satellites have helped us map Earth in greater detail than we could ever do before. One satellite program tracks meteors that get too close to Earth. It also monitors ongoing tests of ways to divert or destroy threatening meteors before they can collide with Earth. Strategic Defense Initiative, SDI, or Star Wars. In 1983, then U.S. President Ronald Reagan announced research into the development of a space-based defense system. A network of defense satellites would detect enemy missiles in time for the missiles to be destroyed while they were in the air. The system was never completed. Satellites in emergencies. Both communication and military spy satellites are important in major emergencies. Disasters often destroy all means of transportation and other forms of communication, but satellite signals are not affected. Radio and TV stations use mobile satellite dishes as ground stations. This allows signals to be sent up to a communication satellite, which then beams the signal around the world or bounces it to another satellite. Weather satellites save lives. They monitor weather systems, wind speeds, rainfall, and much more. Weather satellites warn us about dangerous storms, such as hurricanes or typhoons. Earlier warning and more accurate information allow people more time to either prepare for the storm or evacuate the area. Meteorologists, scientists who study Earth's atmosphere, weather, and climate, can make better forecasts using satellites. Weather satellites use cameras and tools that measure the temperature in the atmosphere. They can help ships in the ocean by detecting snow and ice at sea. Working together. Meteorologists use weather satellites in different orbits to help them make the best observations. 2 satellites circle Earth over the poles. Another set of these satellites orbit Earth at the equator. Large ships and planes cannot stay on course without navigational satellites to help them find their way. Global Positioning System, or GPS, receives radio signals from 3 satellites that are used to pinpoint an exact location anywhere. Astronomical satellites have the ultimate view of the universe. They look deep into space at the moon, sun, planets, stars, and galaxies. Scientists use these research satellites to study waves and particles moving through space in the hope of understanding more about our universe. Infrared satellites are probing the darkest corners of space and relaying images never thought possible of objects we couldn't see before. Go GPS. GPS was originally developed for military use, but now people across the globe are using this satellite technology to determine where they are. Many cars now have small GPS monitors that can tell drivers how to get from one place to the next. But GPS isn't perfect. It can be disturbed by electrical storms, solar flares, computer failure, or power failures. The Hubble Space Telescope is the most famous U.S. astronomical satellite. The ultimate telescope was launched into its low Earth orbit in 1990, and after 20 years of performance beyond any expectation, the last of its series of refurbishing missions gave it a final tune-up. It received new cameras, new batteries and gyroscopes, a cosmic origin spectrograph, and a renewed expectation of perhaps another 10 years of taking pictures in deep space. As it continues to orbit Earth at 17,000 miles per hour, the Hubble's reflecting telescopes, high-powered cameras, sensors, and other tools act as eyes to the universe. In its first 20 years, these eyes have recorded more than 45 terabytes of data, which is enough information to fill about 5,800 DVDs. The Hubble helped scientists understand starbirth and death, black holes, and the evolution of galaxies. First satellites. Famous scientist Isaac Newton first came up with the idea for an artificial satellite in 1687 after realizing that Earth's gravity held the moon in its orbit. The former Soviet Union took Newton's advice almost 300 years later when it launched the first object into space, the satellite Sputnik 1. Sputnik 1 was about the size of a basketball and had 4 antennas that sent out radio signals. It circled Earth in 98 minutes in an elliptical orbit. The launch of Sputnik 1 surprised Americans and marked the beginning of the space race between the two countries. After 6 months, Sputnik 1 slowly fell back to Earth, burning up in the atmosphere. Living cargo. To prove that a living thing could survive in space, the Soviet Union sent a dog named Laika aboard its second satellite, Sputnik 2, in 1957. She became the world's first space traveler. Sadly, Sputnik 2 was not made to return to Earth, and Laika died. The International Space Station. Space stations allow astronauts to live and work while orbiting Earth for extended periods of time. In 2000, the first crew boarded the International Space Station, or ISS. Then, it was the newest and largest thing in space. Before the ISS, the Russian space station Mir was the largest and most famous space station ever built. This 130-ton station stayed in space for 15 years. Mir's final size was about 98 feet long and 45 feet wide and had 6 components. By 2010, the ISS had grown to be about 4 times larger than Mir, with a living and workspace equal to a 747 jumbo jet. The ISS has almost an acre of solar panels to power it. Space partners. The International Space Station is a joint effort of 16 countries: the United States, Canada, Japan, Russia, 11 countries from ESA, the European Space Agency, and Brazil. Each international partner contributes important elements, such as the highly maneuverable robotic arm built by Canada. ISS travels in low Earth orbit about 250 miles, 402 kilometers up, which allows people and equipment to be ferried back and forth with launch vehicles such as Russia's Soyuz rocket or the U.S. Space Shuttle. The ISS can make excellent Earth observations because it covers 85% of the globe at this orbit. The ISS has the most state-of-the-art laboratory in orbit. Scientists hope to make many discoveries that will help people all over the world. Some of the research will include testing the effects of long-term low gravity on humans, spaceflight-induced bone loss, and long-term observing of Earth's environment. Satellite rescue. After the Columbia Space Shuttle was launched in 1981, satellite rescue missions became easier. Technology on board the shuttles improved the chances of success. Manned maneuvering units, which looked like legless chairs strapped to an astronaut's back, allowed astronauts to move freely outside the spacecraft without being tied to the shuttle. Robotic arms could snag satellites and retrieve them for use in different orbits.
Since the U.S. shuttle program shut down in 2011, NASA has tested and researched
new techniques and equipment to ensure that there are other options for repairing satellites in orbit. Satellite funerals. Space is a busy place, especially with space junk and thousands of aging satellites in low Earth orbit. Currently, there is no international law that says old satellites must be removed from their orbit. Objects in orbit above 500 miles 804 kilometers can stay there for thousands of years. Over time, satellites in some orbits get pulled back into Earth's atmosphere, where they most often burn up before reaching the ground. NASA and other agencies are working with innovative ideas to get rid of aging satellite traffic in space. Conclusion. Satellites are clearly here to stay. Continually evolving satellite technology will continue to change our lives even more in the future. One recent development is Internet routing in space, IRIS, which allows for more instant transfer of voice, video, and data communication to remote areas. Researchers have recently developed satellite imaging programs that let farmers track herd animals or monitor water supplies and irrigation levels. Improving satellite technology adds greatly to scientific knowledge. Satellites make it possible for us to communicate information quickly to people all over the world. Satellite images help us to come up with better ways to protect our planet. Research satellites will continue to probe our galaxy, helping us unravel the mysteries of the universe. Explore more. On the internet, use www.google.com to find out more about the topics presented in this book. Use terms from the text, or try searching for glossary or index words. Some searches to try: satellites, global positioning system, or Hubble Space Telescope.